Our topic today is going to be dividing polynomials. So we've been working with other operations, adding, subtracting, multiplying. So now we're going to get a little more complex with these and work on doing the opposite of multiplying. So in our previous problems, we had two binomials, or a binomial and trinomial. We multiplied them together to make a trinomial. So here we're going to kind of reverse the process. In our area model or tile model here with algebra tiles, we have represented on the left side this x and this -3. So we have 3 minus 1s and we have an x. In our product, which goes over here, we have an x squared and we have 4 positive x's. We have 3 negative x's, and that gives us a net of plus x that we see here. And we have 12 negative 1s. So altogether, these give us our -12 that we see here. Now the question is, if we have that, what is the other binomial that we were multiplying? So we're going to divide this one by this one and come up with the fact that this looks like we need an x right here, because that would give us x squared and these 3 minus x's. And then over here we're going to need plus 1 plus 1 plus 1 plus 1. So altogether we get x plus 4 as our result. So the x squared plus x minus 12 went in the lower right. That's our product. The x minus 3 went on the left. That is our first divisor. And then the thing that we get, our quotient, goes on top. So this is lower right. This goes on the left. And our answer goes on top. So this one was already filled out. Let's take a look at filling one out from scratch on number 2. So recall that we just said our thing that we're dividing by, our divisor, is going to go over here on the left. So this is going to be x and plus 1. Our dividend, the thing we're dividing by, or the thing we're dividing out of, goes on the lower right. So if we were multiplying, this would be the product, but since we're dividing, this would be the dividend. We're going to have an x squared. That needs to go at the top left, because that's where our two x terms will multiply. Then we have a plus 7x and a plus 6. So the 7x, we'll see where that comes from in a minute, but let's look at our plus 6. So we have a 1 here, and the only way we can make plus 6 would be to put 6 right here. 1, 2, 3, 4, 5, 6. Because we can't get any 1s up here since we're multiplying by x, or dividing by x. So we have our x squared and our 6. Now if we draw in our 7x, we have 1x, and then 2, 3, 4, 5, 6, 7. So now we have the entire thing represented. X squared, that's here, 7 x's, and then 6 plus 1s. On the top then, in order to make this work, we would need an x right here, and then we would need a 1 for each of these. So we get x plus 6 as our answer. If we want to check that answer, we can go back to what we learned last and try the reverse. So let's look at x plus 6 and x plus 1 and try to multiply those together. So with double distribution, that would be x times x plus 6 plus 1 times x plus 6. So we'd get x squared plus 6x plus x plus 6. We combine our like terms, and we get x squared plus 7x plus 6. So that is the thing that we started with as our dividend, so that means we divided it correctly. Since multiplication and division are opposite operations, we can always use multiplying to check that we divided correctly. All right, so number 3, now that you've seen how this works, give this one a shot. See if you can do this one on your own. Remember where each thing goes, the divisor on the left, the dividend on the right, and then our answer will appear on top. So try this one out, pause the video, and when you're ready, unpause it. Okay, so we're going to put our x minus 2 over here, x, and then negative 2, we're going to shade those in. Then we're going to put our dividend on the right here, so we're going to put x squared right there. Then we have a plus 8. So here we have 2 spots that we can make 1s, but we need these to come out as plus 1s, and we need even numbers of rows and columns. So I'm going to take that 8 and divide it into 2 sets of 4. Now remember that to make these positive, we must be multiplying up here by negative 1. So we're going to end up with 4 negative 1s up here, and an x up here. Then our rest of our x's are just going to fill in. This is x times minus 1, so we get a negative x, and then another. And then over here, we have negative 1 times x again, so this is going to be a negative x, and so will these other 3. So we have a total of 1, 2, 3, 4, 5, 6 negative x's, which is exactly what we wanted to have. So our answer across the top is x minus 4. And again, if you want to check it, multiply x minus 4 times x minus 2, and you'll see that we come up with x squared minus 6x plus 8. All right, so now it asks us to look back at number 1, and it asks us what is the difference between x squared plus x minus 12 and what's in the picture. So that's this one here. And I think the idea here is we have a plus x in our dividend, but down here we have 4 positive x's and 3 negative x's. So it's not just as simple as it was here where we just added up all of our x's or added up all of our negative x's. We had a mix of x and minus x. So I'm guessing we're going to end up with that here. We're going to go ahead, I'll do number 5 with you, and then we can have you pause and try some. So this is going to be x and negative 2. And then we have an x squared here. And then we need a minus 4. So those need to be broken up between these 2 lines evenly. So minus 1, 2, 3, 4. We get our negative 4 here. And then we know that we need an x right here in order to make the x squared. And then to make these minus 1s, we're going to need some plus 1s, because this is a positive 1 and a negative 1 multiplying to make negative 1. So when we fill in our x's, we'll have 2 positive x's here, and here we'll have 2 negative x's, because this is a negative 1 on the left times an x on the top. So when we combine our like terms, we get x squared from here, we get negative 4 from here, but the plus 2 and minus 2x cancels out. So that's how we end up with just x squared minus 4 and no x term. So our answer, our quotient, was x plus 2, which is the opposite of x minus 2, so that's how we canceled out all of our x terms. So try, on number 7, go ahead and note on your paper that this should be 2x squared plus 7x plus 5, not plus 4. It'll be hard to divide that evenly if you don't change that to 5. Once you do, go ahead and try number 6 and 7. Follow the exact same process that we've just been doing. Make sure that you are getting the right answer, and if you want, double check by multiplying. I will go through these two, but pause the video and try them yourself first, and then unpause it and I'll go through it. Okay, so let's start with number 6. We have 2x, so we're going to put x, and we have plus 1. So that's our divisor. In our answer, we have 2x squared, so those need to be evenly split between our x's. So we have an x squared there and an x squared there. That means we know there's going to be an x here in our answer. Next, we have a minus 3. So on our 1 row, we're going to need 3 negative 1s. So we have negative 1, negative 2, negative 3, meaning that we must be multiplying this as a positive 1 times a negative 1. So we did 1 times negative 1 and got 1 3 times over. If we fill in all of our x's now, we have a negative x, a negative x, and a negative x here, then another 3 negative x's here. These are all negative because it's positive x on the left times negative 1 on the top. So we'll shade all of those in, and that's negative 6x. But notice that our answer only has our dividend only has minus 5x. So we also need an x right here where we have 1 times x. So now we have minus 6x and plus 1x will come up with the right answer. So our quotient is going to be x minus 3. And to check it, we'll do x minus 3 times 2x plus 1 and find that that equals 2x squared minus 5x minus 3. You can do that check using either the area model or the double distribution model that we talked about in the last section. Number 7, you should have done this one as well, or at least given it a shot. On the left, we're going to have x plus 1. Then we have 2x squared. Well, there's only one x row, so both of those x squareds must live in this row right here. Meaning our answer is going to have an x here and an x here to create those x squareds. Then we have a plus 5 for our third term. And there's only one row with constants, so these plus 5 have to be here. And that means that they're all 1 times 1. So we have 5 for our column as well. Filling in all of our x's, we have 1, 2, 3, 4, 5, 6, and 7. So we end up with everything working out correctly, and our quotient is 2x plus 5. Had you tried this with 2x plus 4, we would have come out slightly differently because we would have only put 4 1s here, meaning we would have only put 4 1s up here, and we would have come up with 2x plus 4. But if we went back and counted, we only have 1, 2, 3, 4, 5, 6 x's. We don't have the 7 that we need. So the reason this needed to be a 5 is so that this divides evenly. We'll talk more about dividing evenly and having remainders coming up, but right now just know that it's kind of like our division that we've done with just single numbers. If we had 22 and we try to divide that by 7, then we're going to end up with 3, but we also have 1 left over. So we end up with 3 and a remainder of 1 because we take away 21, we get 1, and we can't divide any more 7s into that. So if we don't want to have a remainder here, this needed to be a 5. All right, so you have some homework to practice this. There are 6 of these problems, just like the ones we did up above in the notes. So you should be able to handle those. Just remember to keep everything in the right spot. This divisor goes over here. So we're going to put on the left side is the divisor, then our dividend, that's a terrible line. Our dividend is going to go on the right side, so dividend goes here, dividend, and then our quotient is going to appear at the top, so this quotient is our answer. And all of these should divide evenly, so you shouldn't end up with any remainders today. We'll talk tomorrow about things that don't divide evenly and how we handle those remainders. But that is all for the notes for today.